Hello students, my name is Sungjoon Park, your tutor. This course is for international students and we are gonna deal with some basic math. So I'm gonna show you my curriculum of this course. So first, this chapter is set, and then this proposition is kind of English, like English thing. It is more like an English, not a math, calculating math. And the third one will be number systems. There will be a lot of groups of numbers, like integer, I think you heard of it, and some real number, and like these complex numbers. And we are gonna deal in this chapter. And this equation is the most basic thing in all total math. So like, you know, x plus 1 is 2, like that. Getting this variable. And inequality is just changing this equal sign to inequality sign. And this chapter 6 and 7 will be a plane coordinates. From this chapter, we are gonna go on to the plane. We are gonna draw a lot of graphs like this. This is a plane coordinate. We are gonna draw some graphs, and this will link into this function. Actually, this function is our major goal of this course. To understand function is very important in the math. And this 12 and 13 will be trigonometric function and trigonometry. These two are for engineer students. I think engineering students will need this. So, and then we are gonna, so 12 and 13 and 14 are same, these trigonometric functions, and graph will be 14. And 15, from 15, new concept will begin. And 15 to 24 will be a second half. This differentiation and integration, these two are important in this university math, especially economic students, economic major students. They use this differentiation a lot, and also this integration. And it goes without saying that it is very important to engineering students because they use this every day. And to understand this differentiation, limit is very important. This 15, if you understand this well, 15 well, then these on the last things will be easy for you. But if you don't understand this well, then this will be like a hell. Okay? Then if you look this like broadly, this function has 4 chapters, and this differentiation has 5 chapters, and this integral has 3 chapters. These 3 form almost all of our lecture, my lecture, and these 3 are very important concepts. If you understand these 3, then I'm sure you understood all of my course. Especially this chapter 24 is hard, and the starting of the second half, this chapter 15 is hard. So this was the curriculum of my course, and I'm gonna start with the set. So the table of contents. This set is a way to express some mathematical groups. So it is important. This set means, you know, in English word, the set group. So the definition of set will come first, and expression of a set, subset, set operations, the number of elements. Definition of a set. A set is a collection of definite, distinct objects which are called elements. In this definition, these two words are very important: definite and distinct. This has to be an obvious object, right? So there will be two examples, and looking at two examples, you have to distinguish this if it is a set or not. First, a collection of the beauties. What do you think of this? Is it a set? I think it's not a set. Actually, it's not a set, because everyone in the world don't think that a same person is beautiful or not, right? Which means in some rare exception, there will be a person who doesn't say that person is beautiful or not beautiful. So it is the first example, so I'm gonna give you an example, which is Britney Spears. Do you know Britney Spears? I think you know. Britney Spears is almost obviously beautiful, but some people who don't like her will say she is not beautiful. If one person say she is not beautiful, then it is not a set, because it doesn't have a distinct, definite object. This Britney Spears is not a distinct and definite object, right? There has to be one single standard which all people can agree. But if one people can't agree, then it is not a set. So this beautiful is kind of abstract word, so it's not a set. An example 1.2. A collection of natural numbers smaller than 10. Is this a set? Yeah, this is a set, because we all know that this is the component. There is no other number which makes this right. So this 9 thing is all. So anyone who learned a little bit of math will agree with this. So this is a set, because these 1, 2, 3, 4, 5, 6, 7, 8, 9 is definite and distinct object. Okay? So, expression of a set. There are two ways of describing or specifying the members of a set. So we learned about the definition, and now we have to learn about how to express this set. Because in some sets, the members, there are so many members objects, so we can't write all of it. So there comes a set builder form. Oh, before we start this, extension was first. Extension is just the way we write all of the components here inside. And in this set, we say the name of this set is A, and this thing here and here is a brace. We have to use this brace to express a set. Then here, brace here. And this set builder form makes to express a little easier. X bar X is even number smaller than or equal to 10. So this was the thing we've seen in the last slide, which was example 1.2. So if we say this like in English word, this is exactly the same meaning. Oh, no. Even number 2, 4, 6, 8, 10. this is exactly same with this, but we are saying this as an English word with condition here. X bar X, this form is very important. X bar X has to come first and is after is, this condition will come out. Okay? So now we are going to learn about subset. If every member of set A is also a member of set B, then A is said to be a subset of B. So we draw like this, and before we start here, this drawing is called Venn diagram. I'm gonna give you the spelling. Actually, we say this as a Venn diagram. So, like this, then A is composed of 1, 2, and B is composed of 1 to 3, right? Then every member of set A and B, which is 1 and 2, is also member of B, which is 1 and 2. This is inside this B set, right? Then we say A is subset of B, which we say denote like this. So this is a definition, but this is for every A component inside A set. This A component is also a member of set B, and A is subset of B. This is a relationship between the inclusion. This includes all of this A, like this. Okay? So this is the bigger one here. I'm sorry, and this is the smaller one. So, example of a subset. A set of all men is a proper subset of the set of all people. This is obvious because all of the people can be divided into two groups, which is men and women. And these two are subsets of all people, right? Because all members of men are all members of people. I am a man, but I am also a people, right? So, this is easy for you to understand. In the second one, an empty set is subset of every set, and every set is subset of itself. So this is a notation of empty set, which means there is nothing inside. We say like this also, nothing inside the brace. And this is also subset of A, and A itself is subset of A, because every member of A is every member of A. This is just kidding. Yeah, it is easy. An obvious but useful identity, which can often used to show that two seemingly different sets are equal, which means if this is right and this is right, which means that both sides are right, then these two are same. I'm gonna show you here. If this is right, is it right? Yeah. This is right and this is right. Then we say A is A. I think you can think this and show it by yourself. So let's go on. So set operations. So these two are the next concept, and this is sum and this is intersection. So you have to memorize all these notations: going up, going down, and going to left or right, right or left. These two are subsets, and this is sum and this is intersection, which is the sum will be, I'm gonna color this. Can you color this? What is this sum? This will be all this point. by the way, this intersection, which is literally the intersection in English, is this point. This part, actually. So it's easy. And set operations. Now this C comes out, and C is not a constant or some number. It is just C alphabet. And if you write the C on the upper right side, and this we say this is the definition. If X component is inside the U and X is not a member of X, which is the outside of A. So here is set A, then the outside is set AC. We say this as a complement set. So this was the definition, and this 226 is some properties you're gonna look. So number 2, the complement of A is the outer side, and the complement of this complement A is itself, right? This will if you complement this thing, and this will come out, right? And number 3, A and the complement of A, if the intersection of A and A complement will be 0, because this complement of A is by definition like this, because there's no member inside this A. So these two have no common objects, right? And number 4, if this changed to sum, then it'll be a U, which is the total set, right? Because these two have no common thing, and this is the outer part and this is the inner part. I'm gonna erase this and do it again. This inside part and this part. If you sum this part and this part, then it will be a total set, right? And this one, what was this? This was an empty set. Empty set, the complement of empty set is total set, right? And total set complement is empty set. These two are same meaning. So set operation 3. So this is the difference set. We've learned about this one, it was subset, and this one, sum set of sum, and this was intersection of set. And we learned about this small c on the right upside, and this was the complement set. And this minus sign is difference set. This is not a totally same to the minus we do in the algebra, but this is different. This means some different thing. This is same as this thing. And the definition here is x bar x is inside A and outside B, which means inside A is this part, right? And outside B is this part. So what is the common part of these two? The answer will be this thing. Oh, I'm gonna use this one. Oh. Colors are not good. Right? This one. Can you follow me? So this part, without this intersection, is A, B. A minus B. Actually, it's not minus. Different set of A and B. So, De Morgan's law. We use this without proof. I think you can prove this by yourself in this Venn diagram. Because you color this right side, left side, and right hand side, then these two will exactly be same. So, if you if you get this 2 inside, then this notation will change like this. This is also same with this 2, right? And you have to memorize this because a lot of proving problems of set contains this law. This law is, I think, the most hard concept in all this chapter set. So this comes out a lot of time for hard questions. So the number of elements. So this is not a notation. It's actually a notation, but it's not an operation. But this means the number of elements in the set, right? You know this? Before we do this, I'm gonna give you an example. Let's say A is composed of 1 and 2. Then what is NA? The number of A is 2. Oh, it's easy. Then, if we say this is kind of hard. But before we do this, NA P. Let's say this is the total set, and I'm gonna draw the Venn diagram. Let's say A is here. We usually draw like this because we have to express this intersection part and also this outer part, and this is the most easiest way to express like this. So we draw like this, and I'm gonna color this parts. This part will be here, right? And this part is here, right? Oh, no. Here. And this part is here. So if we sum this A part, yellow part, and this purple part, then we are summing this intersection part twice, right? Can you follow me here? Then we have to subtract one time. So we are doing this. This new color. This. Which means we subtract this one time. Then the number will be same. So you have to memorize this. And there is one more application, which is A, B, C. If there are 3 sets, then it is more difficult. This will be, we do this sum first, and we have to get rid of the intersections for one time because we added for twice. And we have to add at the last time the intersection of all. Because if we subtract 3 times, then we subtracted this for more than once. We have more. So we have to add this once again. So using this, I recommend you memorize this, because this is easy to memorize, but this is hard to memorize because there are 3 steps: adding, subtracting, and adding. And the final example is about this one. So let's see the final example. There are 50 high school students supposed to apply for entrance to a university. They can apply to 3 prestigious universities, Yonsei, SNU, and KU. Welcome to Yonsei. This is the biggest letter, and these 2 are small. And 27 students applied for Yonsei, and 25 to SNU, and 19 to KU. Wow, the most students applied for Yonsei. And 8 students, all of them. Wow, they must be smart. By the way, how many students applied to 2 universities? So there is Venn diagram here, and let's say Yonsei is set A, and SNU is set B, and KU is set C. Then in the problem there was 4 things actually. The total students is, the number of total students was 50, and the number of students who applied for Yonsei was 27, and the number of students who applied for SNU was 25, and the number of students who applied for KU was 19. So, and actually in the example there are one assumption. The assumption of this problem is that a student can apply for more than one university. There are no students of this 50 students who didn't apply. No one gave up. No one gave up. So then, and there were 8 students who applied for all 3 universities. So I'm gonna point here. This one first. It's here inside, because 3 intersections of 3 components here, and 50 is all this part. So I'm gonna say here 50, and this A is all this part, blue part is 27, and this green part is 25, and this red part is 19. So we have to use the equation formula I wrote you. A, B, C was, we sum this at the first step, and we subtract it in these 3 intersection component. And finally we added all 3 intersection of all 3 components. So then in this equation there are some things we know. We know this, we know this, and we know this. And we also know this, because this sum of A set, B set, C set is U. So this is 50, and this is 27, and this is 25, and this is 19. And this is 8, as you see here. Then the final answer, final goal we are looking for was to find students who applied for 2 universities, which is here, and here, and here, right? So these 3 parts are this one, and this one, and this one. But there are minus signs here, and here, and here. And the final answer will be, there are a lot to write. This. So this is I'm gonna move this to right hand side and these three to left hand side. Then actually this is the equal sign, so this will be like this, and minus plus minus and A sum B sum C, right? So these 5 components are the ones that we know in this by this problem. So the answer is 25 plus 20, 27 plus 25 plus 19 plus 8 minus 50. And the answer will be, this is 52 plus 19 plus 8 minus 50. And it will be 71 plus 9, 8 minus 50. And 79 minus 50. And it will be 29. Is it right? 29. I think you can do this calculation by yourself. The most important point in this example is like this, What we are gonna get in this problem is this part. So we have to move this part to left hand side and all the other parts that we know into right hand side. So this calculation is not important, and we got the final answer. So this is end of chapter 1, and the next chapter was, what was it? What was the next chapter? Let's see. I'm gonna show you the next chapter. Next chapter is propositions, and the first chapter was the set, and it was the grouping the mathematical groups, and the chapter 2 is propositions, which is kind of English math. It is not a calculating math, so you don't have to be freaked, and you can just listen to chapter 2 with easy mind. So chapter 1 is done. Bye bye.